is about translations. So let's start with the simplest kind, one that you'd know. Do you know that this is a parabola that's been moved? Think about that for a second. Which way has that one been moved? To the right 3. And by now you've kind of gotten used to that. The negatives are on the left, but you got to go, don't trust that. It goes to the right. Because why? Because the stuff on the inside, you can't trust it. Same thing if I put a +7 out here, you'd know that that means up 7. You don't have to change that one. You've gotten used to this. And I hope you don't get used to this. Always trust the y's, but don't trust the x's. That's not it. It's about what's in the parentheses that you can't trust. The reason that matters is this is the equation for a circle. And it's got x's and y's, and they're both in parentheses. So you don't just trust the y's. This is a circle, and its radius is not 25. Can anybody do it? 5, because it's like a squared pattern. Everything's squared, so that's really 5 squared. So the radius is 5. And I want you to know that you can't trust the y here. It's not just about trusting the y's. It's about inside and outside. Because it's on the inside, you can't trust it. Seems like it's moved down. The circle seems moved down 5, but it's not. The circle is moved up 5 from the origin. And this seems like it's moved to the right 3 because that's where the positive numbers are, but it's actually left 3 and up 5. And that's where the circle would be. It's left 3 and up 5. And then you put a dot there as the center, and it's got a radius of 5. So it's going to be like that-ish. That's where that circle is, and you don't trust the stuff on the inside. So same thing, here's my function. Compared to the parent one, it was moved. So would you agree on the parent function, y equals x squared, the parent one, there would have been the point 0, 0. Would you agree with that? On this one, is there a spot at 0, 0? No. My question is, where did it move to? The point that was at 0, 0 has moved somewhere else. It's been moved to 3, 7. Now I want you to think about what you did there. You didn't subtract 3 from your x. You added 3 to your x. And your y value of 0, you added 7 to that. 3, 7. Also, because this is in vertex form, you should be able to just go, oh yeah, that's 3, and you don't trust the negative there, so it's positive 3, 7. All right, but what if I gave you another point? Like, would you agree on the original graph, if I put in 2, I would have got 4? Would you agree that 2, 4 is not on the new graph? But where would the point 2, 4 have moved? Here's the easy way. Do you think we should subtract 3 from the x? No, we should add 3 to the x. And do you think we should add 7 to the y? Yes, you can trust that. So it's 11 for the y and 5 for the x. You see how I got that? I took the original point and I did the opposite of what I would think here. I didn't subtract 3, I added 3. And here I did add 7 to the y. So my new point was 5, 11. All right. So let's get an equation, y equals 2x plus 5. Would you just please find me 3 points on this? 3 points on that equation. This is right off the top 20. And this is why it's important. You got to be able to take a function that you just don't have memorized and find some points on it. Owen, can you try this?
How many points did you have?
3.
3.
Carter Krebs, give me a point.
Thanks. Got it.
You put in what? -1, and you got what? -1, 3 is on that graph. Good. Lillian Miller, give me a point.
0, 5.
Put in a 0, you get a 5. Correct. Mariam, give me a point. 1 comma 7. You guys agree that those are points that are on this graph? Okay, good. Now, what if I took this graph and it's called f of x? Would you agree that that's a typical name for a function? But what if I did this to it? I said I want to do 3 times it minus 4. So I ask you, did I just change the x values or the y values by putting this 3 in front and this minus 4 in the back? The y values. Can I trust what I did? Yes, you can trust the stuff on the outside because it's not on the inside. So that means I should times it by 3 and subtract 4. Would you agree that the order matters too? Because if I just subtract 4 and times by 3, it's not the same as timesing by 3 first and then subtracting 4. You'll get different answers. So the order matters. Should we do the normal order? Yes, we're on the outside. You can trust the stuff on the outside. Normal order. So what's normally first? Multiplies by 3 or subtract 4? What's first? Multiply. Okay, so do it. By take the y values, do what we just said to them. Presto changeo, you'll have a new y value. Do you trust the stuff on the outside? Yes. So I'm going to times it by 3 first. And then I'm going to subtract 4. 9 minus 4 is 5. Did you get 5 for that first one? Good. 15 minus 4, 11. And 21 minus 4, 17, I think. Anybody verify the 17? Had it before I did? Okay, good. All right. There's my new point. Why aren't the x's changed at all? Because I didn't touch them. There's nothing on the inside. Now I'm going to squeeze in something on the inside. I'm going to put a 4 in there. No, wait. I'm going to put a 1/4 in there. Do you get that my x's now have to change? Did I stretch them or shrink them? It seems like I shrunk them, but you can't trust that. So I stretched them. You are correct. So should I multiply by 1/4 or should I multiply by 4? Multiply by 4. So I'm going to times them all by 4. Negative 4 times 0 is still 0. Wait 1 second. 4 times this is 4. Can anybody verify I have those numbers right? Okay, cool. Then there's my new function with the x values and the y values. Yes. All right, so let's get to another one. Except this time, I'm going to draw you a picture of it. Do you guys recognize that one? If it's the normal square root function, can you give me 3 points on it? I didn't give you an equation, but you could write the equation. Would you agree 0, 0 was on it? How about 1, 1? Because if this is the function, you put in a 1, it's the square root of 1, which is 1. And how about 3? Square root of 3 work out nice? No. How about 4? Would that work out nice? Yeah, square root of 4 is 2, so 4 comma 2. So here they are, 0, 0, 1, 1, 4, 2. Okay. Notice I started with a drawing that time. Now what if I want to take my function and do this to it? Here's f of x, but I'm going to throw in a 4 on the inside. Will that stretch it horizontally or shrink it horizontally? Shrink. So do you think we should multiply all of our x values by 4? No. What should I do with them? Divide them by 4. Divide them by 4. So I'm going to divide this by 4. 0 divided by 4. 1 divided by 4. And 4 divided by 4. 4 divided by 4 is the easiest one. It's 1. 1 divided by 4 is, well, it's 1/4. And 0 divided by 4 freaks people out. But what is 0 divided by 4? 0. It's just 0. And if I graphed this new thing, I'd be graphing 0, 0. Well, that's in the same spot. And I'd be graphing 1/4, comma 1. Ooh. 1/4, comma 1 is like there. And I'd be graphing 1, comma 2. It's like the whole root got scrunched down that way. Horizontally shrunk.
Technically, it's still go on forever.
Louder?
Wouldn't it technically still go on forever?
Yes, it does. It does. This one goes on forever, so does that one. But they're kind of squished. Okay. I feel like you're getting this. And I feel like we should do a few more of these slides because so you can see what the problems are kind of look like on the homework and on the tests. All right. Just a 2-second reminder before, I'm not going to redo this because you did it yesterday, but is there any of these topics that you don't totally get? Yes.
Can we actually go back to the page?
You can ask me a question about it. I can't move back because it'll mess up the recording.
I'm confused on how the first thing that we did with the multiplying by 1/4.
I will do another one like it. Okay? Would you agree that whatever function I had before just changed when I put a 4 in there? Okay? Doesn't it seem like that would make it 4 times wider? So you can't trust it, and you got to go not making it wider, making it narrower. This would be a shrink horizontally. On the other problem, it was a 1/4, and it actually meant times 4. In this one, it's a 4, so it actually means you'd multiply all your x values by, what do you think? By 1/4. Shrink them all down, 1/4 is big. Okay? So when it's on the inside, you can't trust it. If it says a 4, that's not going to be a stretch, it's going to be a shrink. And so you don't multiply by 4, you divide by 4. Or you could say multiply by 1/4. Okay, so back to these. Increasing, decreasing, constant, local maximum. How about this? You just tell me this. Remember, this one was weird. I don't like it because it's kind of confusing. I'm going to put this arrow going up like that because that's what the little tip says it does. Do you get that meant these were both local minimums, or sorry, maximums, but neither one was an absolute max? Okay. And this spot was a local minimum. Keep the questions about this page now. If you want to change topics, we can't do that right now. Okay.
About the, like, not trusting thing.
Yep, yeah, we'll come back to that later. But right now I got to review this with you because it was important and there's a whole bunch of things. All right, if I asked you what the x-intercepts were of this, can you see that'd be this and this, the x-intercepts? What's a funny way to ask somebody the x-intercepts? Tell them that y equals 0. If I wanted this, which is the y-intercept, I could tell you that I want you to set x equal to 0. So that's x equals 0, aka the y-intercept. These are the x-intercepts. A couple other reminders. You're going to be expected to know that those are also called roots. This is a root. This is a root. And last but not least, they are called solutions. Okay, so if I ask for the solutions, that's these guys. All right. And if this spot is at -6, comma -1, and this spot right here is at -1, comma 3, if I asked you that where it was increasing, you'd go, well, it's increasing in here. How do you say it's increasing in here? By saying it goes from -6 to -1, it was increasing. All right, with that review, see if you can answer all of these. That's a tremendous amount of separate little questions. Only one of them, in my opinion, is hard, and it's number 49, and we'll talk about it. The rest of them, you should know how to do, and that's why I'm stopping to do them with you. Try to tell me what each of these are, and notice there's no arrows on the graph. They're just dots on the ends. All right, I'm going to pause for a minute. We try to answer those questions. This is really critical moment. Because that's literally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 16 things, 15 of which I think you should be able to do. I'll pause for a minute while you try that. Okay, answers. The domain of F. This is the way I'm thinking. This is called metacognition. Thinking about my thinking. I'm thinking, well, this whole thing as a function isn't increasing. It's got increasing, it's got decreasing. But my domain is from left to right, so it's from -5 to 3. And domains, you're supposed to use brackets if it touches. And it does. Determine f of -2. That's where I put in x is -2, and I go up here and I get 2. And the assumption there is they want the y value. We already gave you the x value was -2. All right, next the x-intercepts. I could just list them as -4, -1, and 1. Now, I'm the teacher, so I get to say that. What if the teacher was mean and like marked you wrong for that? Maybe it's because they wanted them as a point. They should really have said that. -4, -1, and 1. Or as a point, since they're x-intercepts, you could say their y is 0. So -4, comma 0, -1, comma 0, and 1, comma 0. The zeros, same. You're supposed to know that the zeros are the same as the x-intercepts. And the solutions, well, that they are saying how many solutions. The number of solutions to y is 1. And I say f of x, that means y. Y is 1. Okay, so now I'm going to draw a line at y is 1. Here's where y is 1. How many solutions do I have? 1, 2, 3, 4 solutions where y is 1. Process that. It's important. One of the most missed questions. Any questions about that question? Okay. Then the intervals where f is increasing. Well, it's increasing from here to here, which is -5 to -3, and it's increasing one other place. I'd love a volunteer. Let's go with Sylvia.
0 to 2.
0 to 2. Can you verify that one? Nick?
Yes.
Okay, good. And the local maximums. Is there multiple local maximums? Yes, there is. That's a local maximum. That's a local maximum. 2, comma 3, and -3, comma 4. Find the maximum, if it exists. When they say the maximum, they are implying, and I would have answered this question on a test, like, do you mean absolute maximum? Yeah, that's what they were really asking. The absolute maximum is this one because it was higher than the other one. Okay, so that would be -3, comma 4. Next one is the range. That's from low to high. It goes from here to here, which means -5 to 4. Y equals 4 is one thing, and that is when y is 4, they're implying they want to know what x is. So here's where y is 4, and there's the x, which is -3. The y-intercepts, there's 1 right there, and it's at 0, comma -1. Where is the function greater or equal to 0? I like to do it this way. Here's where the function is above 0 when you're in this zone. And this is where it's equal to 0, and it's right on that line. Okay, so where is it above 0? Well, from here to here it is. So it's from -4 to 1. -1, thank you. -4 to -1. And it touches, it's got a greater or equal to 0, brackets. And the other place where it's above 0 is from here to here, which is from 1 to 3. It's above 0 in that zone, or equal to 0. Brackets. Does it appear to be odd, even, or neither? Well, if it was like this, it would have been even. If it was kind of like this with origin symmetry, it would have been odd. It's neither. Where is it decreasing? From -3 to 0. And from 2 to 3. I could see the argument for parentheses or brackets. I would want you to use parentheses. Probably wouldn't have marked brackets wrong, because you could kind of make an argument for brackets. List the local minimums, if any exist. Well, there was one low spot right there. It was 0, -1. But it's a local minimum. The minimum, there is a minimum. It's that spot. And that's the lowest of them all. And how low was it? Well, it's where it is. That's at -5, -5. They want you to list a point for the minimums and maximums. Okay, yay. How many of you did really well on that section? Okay, good. Yes.
Do you need a union for 49? Because it's.
I was thinking about putting a union in there, and I think you probably should, yes. Any other questions?
So would 3, 1 not be a local minimum?
3, 1. That's a good question. Here's a question.
The same thing.
An analogy I gave the other day was, would water collect there?
I guess not.
No. And so you need a point on either side of it that's higher than it to be a minimum.
To be a local minimum.
Yep.
But it could technically be if.
There is a difference between a minimum and a local minimum.
Okay.
Yep. This one was the minimum of them all. It's the lowest spot. All right. So, and that is an interesting one. But I get what you're saying, because it's a absolute minimum, but not a local minimum. And I get how that's confusing. But I'm going to stick with my analogy. That is not a local minimum, because it needs to have spots on both sides that are higher than it. Okay, so let's move on to this. These are ones you should know. There's the first one. I'm just doing a quick sketch. Please do a quick sketch. Not distinct points, quick sketch of each of these functions. I mean, like in 1 minute. We'll see if there's any you don't really know. I'm going to pause for a second. Try to answer all the 5 remaining ones in 1 minute or less. Okay, let's see how you did. Here's x to the third. Here's the square root of x. Here's the absolute value of x. I'm not being perfect on all these, but it's basically a V shape. The 1 over x, I'm going to be a little more careful here. I'm going to put a dot there and a dot there, and then I'm going to try to connect like this and get closer and closer to those axes, because on the axes is where the asymptote lines would be. And then over here, cube root of x. I'm going to also be careful on the 1 and 1, 1. Cube root of 1 is 1, of course. And it looks something like that. That's probably the hardest one for you, was number 6. How many of you, be honest, didn't know what number 6 was going to look like? Okay, imagine it was a test. You could have found points. And if I had showed you 1, 2, 3, 4, 5 points, you can all connect dots. Okay, so my point is, you can't be really stumped on these if we put you on a test, because you can make an XY chart. Figure out what it looks like. Okay, moving on. This is just saying A will be a vertical stretches. F is not a thing. It's the f of x. See, this is f of x. And A, B, C, and D are the changes to f of x. So f isn't like a change. F is just part of f of x. B will be a horizontal. And I'm saying stretch, but do you get these could be shrinks if you make them fractions? All right. C is a horizontal move, as in left, right. And D are vertical, as in up, down. Any questions on those? Which ones can you trust? The ones that are on the outside. You can trust this to do what you would think, and this will do what you would think. The ones on the inside, not at all. Sophia, could you shut the door, please? Thank you. So what transformations are happening here? What's that 5? What kind of stretch? Vertical stretch. That 3, careful. It's horizontal shrink. Seems like it's timesing by 3, so you won't times by 3. You times by 1/3, or you could say divide by 3. And this seems like it's moving towards the negative numbers, so therefore left, but it's actually moving right. And the most nasty thing of all is that these things on the inside have to be done in the opposite order. Do you get normally you would do this first because it's a multiply? So then you wouldn't do that first because you're on the inside. You would start here and you would move it 4 to the right first. Then you would do a horizontal shrink by a factor of 1/3. You'd use a 1/3 on it, not a 3 on it. Okay, moving on. Here's a point, 5 comma 8. It was on the parent function, which we don't even know, but it was f of x, whatever it was. But g of x is a new function where it's been stretched and moved and all kinds of stuff. Just watch me do this one, and I think you'll understand it, I hope. I trust this plus 6 here and this times 5. And I'm going to do that to my y value. Do you get what I mean? I can trust that stuff because it's on the outside. It's not in the parentheses. So, which should be first, though? Multiply. And we trust it. So we do it in the normal order. So I'm going to times by 5. 8 times 5 is 40. And then I'm going to add 6, 46. Do you get how I got that 46? I just did the times by 5 and the add 6. Just like you'd expect. But on the inside, you can either wrap your head around this, that I have to do these in the opposite order and do the opposite thing. It works, but let me show you a way faster way. 3x minus 4 equals 5. If I just set this equal to this, it'll force me to do it in the opposite order and the opposite thing. Because look, I'm going to have to add 4 to both sides. See, that's the opposite of minus 4. And then I'm going to have to take and divide both sides by 3. Not times by 3, but divide by 3. Would that work on the other way too? No, it won't. It'll only work on the x. Why? Because it's on the inside. And by setting it into an equation, it's forcing you to do PEMDAS backwards. Final answer, x equals 3, and that's what my new x is, 3. I could do that this way. I could take this 5 here and say, the first thing I would do is multiply, but I can't. I got to do it in the opposite order. So I'm going to do the subtract 4, but it's not a subtract 4, it's an add 4. So 5 plus 4 is 9. And I feels like I should times it by 3, but I don't. I take my 9 and instead I divide it by 3. And that's how I get the 3. So you can do it either of those two ways. Thinking through the exact opposite order and the opposite thing, or just set it in an equation. It's so easy. See if you actually learned anything. Here's another one just like it. Here's your x. That's the complicated part. Goes with that. Figure out what your new x would be. And on the y value, just keep it simple. Take the 8 and trust these things. Remember, that's a negative 2 times. There's a times in there. I'm going to pause for a sec while you try that one. So let's see how you did. Let's take our 6x minus 4 equals 14. How many of you did it this way? I think it's the easy way. If you didn't do it this way, watch how easy it is. I just add 4 to both sides. Makes it 18. 6x equals 18. Divide both sides by 6. It's 3. Who had 3 for the new x value? Okay, good. How about the y value? Well, I'm going to take this 8 here, and I'm going to times it by negative 2. Why am I doing that first? Because multiply comes before add or subtract. Now that 14, a lot of people go, but they're subtracting 14. No, they're not. The negative was on the 2. Okay? So we're timesing it by negative 2, and then we are adding 14. So that's negative 16, and then I'm adding 14. So it's negative 2. 3 comma negative 2. Who had the same answer as me? Yay, I win. Yes?
So I was kind of thinking of it because it's the 14 minus and then all of this. I was thinking that it's 14 minus.
Why don't you see if you come up with the same answer? Because if you get a different answer, don't do it that way. Because there is only one right answer. There is more than one way to get to the right answer. But if you get an answer other than negative 2, the way is not working. All right, we have to move on because obviously we're going to wrap up here any second here in this desk. Okay, we could do another, but sliding upstairs. So, here is a typical or your exact homework assignment. All of this was just description. But here is your homework assignment. Starts right there because I can see it says assignment. All right, I'm going to cut this way back. I'm going to suggest you just do 2 of these. Problems 2 and 5. How to do the stuff we just talked. Then I'm going to suggest on this page that you do all of it because it's super easy. You graph square root of x. It's so easy. Then you move it down 1. Then you move it right 1. Then you move it 2 different things. They're all pretty easy. This one, I would strongly recommend you put boxes around this so you can see what's going on. That's a problem. This is a problem. And this is a problem. The one in the middle, that's the parent function for all of them. Now, I would cross some of these off, but I have to tell you, this page is the most important page for your upcoming test. This is the stuff that people really get confused on. So strongly recommend those. You can even skip the last page. Just do those 3. There's a key if you want. Have a wonderful day.